Okay, this how-to video is going to go through how to map step models and mechanical parts to Cadence PCB footprints and into board files to do things like shields and covers and stuff like that. We'll cover various different options and the different methods you've got for mapping step models. So traditionally inside the Cadence PCB tools there's a setup step package mapping. Now you'll notice now you'll get this warning, there's now a new model mapper that's available from the 3D canvas. So if you click on yes, you'll still continue to the old method where you'd effectively get a list of in a PCB footprint specifically it's going to show you the place boundary. I could then go and find effectively the step model that I'm interested in, pick the step model. You would then overlay the two, change the various views to try and get the step model mapped. Okay, quite cumbersome because it was a value of kind of just tweaking values to kind of suit. You'd zoom in, you'd maybe change the view to a top view so you could physically see the pins, look at it overlying and stuff like that. So the new mapper is available inside the 3D viewer or the 3D canvas. So let's click on the 3D canvas and go to there. So you'll see I get a 3D view of my my PCB footprint. There's a 3D mapper tab available to me on the right hand side where the visibility tab is. This was controlled by the symbol representation view. So setup preferences, go to symbol representation. If I'm showing something like only the boundary shape, I'm going to see this type of message. If I show any of the three ones in the middle, I'll see the 3D canvas mapper. If I show the boundary shape again only, I'm going to see this message. So make sure you're using one of the step model options that will allow you to see it. Once you've got that, I can then effectively choose my model type. So this is where I browse for my step model. So go to my step location, let's put in the symbol that I want or the step model that I want, hit return. I would then see the step model. You'll also notice in the drop down Cadence are also supporting SolidWorks parts, NX parts, Parasolid parts, Inventor parts, ASYS parts and Creo parts. So you don't necessarily have to have a step model now, you can use the native CAD models as well to be able to use this functionality if you want to. I'm going to use a step model in this example, so we'll click open. That then loads my step model, and you can see obviously the step model is in a different orientation to the PCB footprint, the XYZ. There's some mapping functionality here. We'll go through several of these over this demo, but let's just start with an auto. So auto's actually done quite a good job of that. It's positioned it accurately on the pads. If I spin around, it looks all right in the Z direction as well. The only issue I've potentially got here is the pin 1 ident. We're not quite in the right orientation, so we can just quickly flip the rotation a couple of times to get that to update. That looks pretty good. I'm happy with that, so I can then effectively close the 3D canvas, save the PCB footprint, and I'm good to go on to the next part. So let's just do a file and open, and I'm going to do a different style of connector. So I've got a surface mount ZIF type connector, the dim ones, you know. So let's go and have a look at the 3D canvas on here. So it's showing me what I need to see here. Let's just go and browse for the step model. So once the step model comes in, again XYZ origins in CAD models and ECAD models don't always match. You can try the auto button, which is the best recommendation to start off with every part. Some instances this will do it perfectly, in other instances the rotation is wrong again. Let's just spin this round. It's looking good, but we'll zoom in again here. Maybe I'm not quite accurate enough on the pin location or the pin center here. You can just manually tweak this if you want to adjust the values to get what you need to get the part to be mapped. So again, that's good enough for me. Close the 3D mapper, save that. Once it's stored in the library part, obviously every time you use that PCB footprint in a design, it's always going to have that step model. So it's recommended to do these things, any step mapping you do in the actual PCB footprint. Let's go and open another one just to show you another different example. So I've got a DIN connector, standard kind of through hole connector, 41612 style, 96 pins. I've got all these holes here, so let's go to the 3D canvas. I get the holes So what we can do is go to the step model again. Use the filter. Again, different rotation, so we'll try the auto button. It's not in the right location, so I could rotate it manually. Again, we're not mapping up correctly, so let's use some of the other options here. So I've got we've been through the auto function. Let's try manual. So I'll get the drag handle, so I can obviously drag and adjust this in the position that I want. Let's just take this out here a little bit. I've got a top option, so I can choose the top face. So this would be effectively, if it's on the board edge, this would be effectively the top face on my connector, because that will be overhanging the edge of the board. What I then want to look at effectively is trying to get the pins aligned. So I can actually use holes on a step model, holes in a PCB footprint, and the way you would do that is effectively you select X, Y, you then pick the pins, and you need at least 2. So I've got a square pin, but let's try that. So we'll pick the surface of those 3 pins there. We'll then pick the surface in the same order, so there's 3 holes here. We'll then click on X, Y, and that then aligns directly into the part. Let's map the model. Obviously the visualization of the board here is incorrect, but it's showing me the correct location because I've got the right surface. The holes are actually all aligned here. I'm looking good, so I'm happy with that. So by using the X, Y, the top or the bottom views, these buttons can then help you when you're mapping parts. So we'll just close that window off and we'll save that, and we're good to carry on. So the final example, I'm actually just going to open a board file just to show you some different options. So let's go to a specific board file. So I can map here. Let's go to the 3D canvas. So there's my 3D view. You'll notice the 3D mapper window again, so I get different options for footprints. If I wanted to look at a footprint, I could select the footprint here. It would highlight the part. There's a full board and a device only, so that would then show me the mapping of this specific BGA on my design, and you could actually make the modifications here. As I said, PCB footprints, I would recommend doing it in the library itself, in the drawing file, the DRA file, which would be the better way to go. But from a mechanical point of view, I might want to actually map things like a cover. So let's do a top cover here. If I haven't got a part generated, you can click on create new model. That will generate a step 3D underscore mech underscore, and then you give the name. I've already got one here for the top cover, so I can browse from my step model. There's my top cover. Once the part comes in, we can use effectively the top option to pick the face of the top of the cover. Let's just maybe use manual just to drag this out so I can then see what I'm mapping. So I then want to use effectively the XY. Inside edge of that hole. Inside edge of that hole. Click the 2 holes on the PCB. XY. That then maps. It's aligned my hole at the bottom as well. My LEDs are all looking good. Got clearance there, so I'm happy with that. So you can then effectively then close the canvas and save the design.